Alright guys, so in this video I'm going to present to you my final project for computer science, and for this project I decided to make a stock price predictor. A little overview about the program: it uses a stock price simulator based on machine learning in order to predict the future stock price of a certain corporation. And then at the end it has an algorithm based on magnitude comparators, which basically tells you if the data that the simulator gives you would result in a good or a bad investment. All right, guys. So getting to the predictor code, first and foremost, I have to say that I did not create this part of the program. I don't know machine learning enough in order to make something like this. I wish I did, but nevertheless, I'll leave a link to the YouTube video that comes with the tutorial if you guys want to check it out. And so getting into the algorithm, like I said, it's based on machine learning, and more specifically, it's based on an artificial recurrent neural network in a long short-term memory architecture. So basically, all that mouthful is that these little dots right here, they're neurons. You code them up. And the long short-term memory architecture means that they could form feedback connections between each other. And each neuron has a connection to the next level of neurons. So this kind of neural network is pretty much perfect for the program we're about to use it for. This is because these feedback connections allow the neural network to process sequential data, meaning that I could give it a bunch of old stock prices. And based off of that, once we cut off the stock market history, it'll start predicting the prices fairly accurately. And you do this just by, it's called training. So you input the old hit stock price into the neural network. And once you do that, that's called like you're training the neurons so they can make the right prediction. So now let's head over to the program code, and I could kind of show you guys how this predictor works. And then I could show you guys the code that I made up that uses this data and sees if the decision you make based on the data would result in a good or a bad investment. So for this program, I decided to use the Google Colab notebooks because I was having trouble getting these libraries into my PyCharm. So if you guys have trouble getting libraries into your IDE, make sure you guys try this out. They're kind of like the Jupyter notebooks we use in class. But other than that, let's get into it. So the first thing that comes is to get the stock quote, so the closing price history of Apple. And if we run the cell, it should pop up. Yep, it should pop up the table for the closing price history of Apple. So after we do this, next comes all the machine learning stuff. So the first thing you see here is that we're going to have to create a data frame based on 80% of the closing price values. So technically, we're going to grab all the values from here all the way to around this area. And we're going to use all these values to train our LSTM model. Next, we're going to have to scale the training data. I'm not too sure the reasoning behind scaling the data, but I just know it's common practice to usually scale the data down prior to throwing it into the neural network. What comes next is to reshape the data into 3 dimensions. So as you see here, the NumPy array with the data is in 2 dimensions, and that's a problem because the LSTM model only operates in 3 dimensions. So once you do that, we build an LSTM model. And as you see here, we're processing sequential data, and these numbers you see here are the number of neurons we're adding to the model. So what comes next is to compile and fit the model. So basically what this code does is grab all the trained values that we have, and then it throws it into the model. This is quite a lengthy process, as you're going to see in a little bit. But yeah, let's move on. So what comes next is to create the testing data set. So like I said before, we're going to use the prior 60 days before the prediction day to try to predict the closing stock price. So that's what this code is doing right here. It's grabbing the last 60 days of the training data array. The last part of this code is to get the predicted values. So here you grab the predicted values, and then we inverse transform them. Because we scale the values down, now we have to scale them back up. So if we run this cell, as you see, this is going to take about a minute. And what it's doing is just fitting all the training data into the model. So I'm going to cut the video, and then I'll be back when this is done. Okay, so now that this is done, we're going to get the root mean squared error, which just tells you how close the predictions were to the actual values. Usually the lower the root mean squared error, the better. And we get a value of 1.66, which is actually really, really low, which means our model predicted the values pretty well. Now we're going to plot the data. And as you see, these values here in blue are the values we use to train the model. The yellow line represents the values of the model's prediction, and the red line represents the real values of the Apple stock closing price. And we're just going to run this to see how close the points were to each other. So it's pretty close. So, like I said, this code was not mine. This is the code I found on YouTube, and I will leave a link to it at the end. This is just a tool I use to make my algorithm. All right, so the code that I made for the simulator will basically tell you what would happen if you made a decision based on the prediction of the model. So what we're going to do is we're going to get the predicted value for March 22nd, and then we're going to get the predicted value for March 23rd. If the model predicts that the value of the stock is going to go up, then we were going to invest. If it predicts that the value of the stock is going to go down, then we won't invest. We're going to do this analysis using 5 different stocks. We're going to use Apple, Amazon, Walmart, Disney, and General Motors. We're going to use the code from earlier to create 5 different neural networks and get the predictions. Then we're going to store the predicted prices into this list. So, as you might imagine, this is going to take a while. So, I'll let you know when this is done. Okay, so now we have the 5 different predicted values. And just as a reference point, this took about 5 minutes, 30 seconds to run through all 5 stocks. And now we're going to get the predicted values for March 23rd. All right, guys, so the predicted values are finally done. It took around 5 minutes, 30 to 40 seconds to finish, just like the other ones. But first, I need to correct something I've been saying this whole time. I've been saying that this entire simulation will be based on March 22nd and March 23rd, but we're actually doing it on April 22nd and April 23rd. I don't know if you guys caught it. We're still executing all the code correctly. It's just that I thought that the 4th month of the year was March instead of April for some odd reason. But yeah, now that we got that out the way, now we're going to generate the actual closing prices for April 22nd, and we're going to store it in this list called the real price 1. And now we're going to generate the closing prices for April 23rd, and we're going to store it in this list called the real price 2. Now we're going to use this while loop, which will tell you whether you should invest or not invest based on the predicted prices. And all it does, it takes the predicted stock price from March 22nd and subtracts it from the predicted stock price from March 23rd. What that does, it gives you the predicted change in stock price. And if the predicted change in stock price is less than 0, then we don't invest. If it's greater than 0, then we invest. And if it doesn't change, then we stay neutral. So let's run that. And we're storing we're appending these decisions in this list called invest. Now we're going to generate the outcome of the real stock price change. So we're basically running this algorithm, but with the actual stock prices to get the actual stock change. Now this code right here basically takes your decision of investing or not investing and compares it to the real change in stock. And based off of that, it'll tell you if you made a good or a bad investment. So let's run that. And now here we print the results. So as you can see, the results aren't too bad. We made a couple of bad investments. The predictor apparently told us to invest in every single one of these stocks, but we made a bad investment in Apple, made a good one on Amazon, bad investment in Walmart, a good investment in Disney, and a good investment in General Motors. This most likely is due to the fact that the simulator is not perfect. If it was perfect, then I wouldn't be sharing it with you guys and I'd be rich. But yeah, I mean, this is a good way to add another line of advice when managing your stock portfolio. And even though it didn't execute perfectly, maybe one day somebody who knows more about machine learning can find a way to make this LSTM model more accurate. Maybe they'll create a potential life-changing algorithm and become the next Warren Buffett. Who knows? But yeah, that was pretty much it for the program. Now we'll go back to the slides and wrap it up. Now, you guys heard me say in the beginning of the presentation that the algorithm I made was based on a magnitude comparator. That's because if you wanted to implement this idea to firmware, you could simply give a high signal to a certain stock if the simulator predicts it to go high. And vice versa, if the simulator predicts it to go low, then you give it a low signal. Once you have that, you could basically send these signals to anything. For example, you could have an LED system that'll tell you which stocks are predicted to go up and which stocks are predicted to go down. Another form of implementation could be that you could send these signals to some type of computer that'll make automatic trades for you and make you money while you just go on with your day. These are just two possibilities off the top of my head, but I'm sure that the possibilities for these are endless. So after this entire presentation, we could basically conclude one thing. Accurately predicting stocks with software is way more complex than it seems. When I went into this, I thought that by simply using a machine learning algorithm to simulate a stock and analyzing it, we could have a program that would accurately predict stocks. However, as you can see, this was not the case. Despite the fact that I didn't get the desired outcome, I'm grateful for the fact that I was able to refresh my Python skills and dip my feet into machine learning and using long short term memory. I've always been interested in this topic, however, I've never really gotten into it. If you guys are interested in the machine learning algorithm that I use in this tutorial, here's a link. It's by this channel named Computer Science, and the guy does a really good job in explaining this code. And other than that, I really want to thank you guys for watching this all the way through, and thank you for a really fun semester. I learned a lot. Good luck in your finals.